Good morning, all of you. Welcome to Sri Jendra Rank Zone. So today we are going to discuss the thermodynamics chapter and thermodynamics and chemistry chapter. Previous NEET questions and previous JEE mains questions. So these are all very important. I want to discuss it. So far we have completed the entire topics in thermodynamics. So let us see now previous JEE mains and previous NEET questions. Previous JEE mains and NEET questions in thermodynamics and thermochemistry. NEET questions. So let us start now. I'll change the format. So question number 1. A heat engine develops a heat engine develops a heat engine develops sorry a heat engine absorbs a heat engine absorbs heat Q1 at temperature T1 and heat Q2 at temperature T2. Work done by the engine is work done by the engine work done by the engine is work done by the engine is J into Q1 plus Q2. This data violates this data. We have to write the options now. This is the question. So option A, violates first law of thermodynamics. Violates first law of thermodynamics. Option B, violates first law of thermodynamics if Q is negative. Violates first law of thermodynamics if Q is negative. Option C, violates first law of thermodynamics if Q is positive. Violates first law of thermodynamics if Q is positive. Option D, does not violate first law of thermodynamics. Does not violates first law of thermodynamics. So these questions, first law of thermodynamics. So this is the question. So a heat engine absorbs heat Q1 at a temperature. A heat engine absorbs heat Q1 at temperature T1 and heat Q2 at temperature T2. Work done by the engine is J into Q1 plus Q2. This data violates this data. So this data, option 1 violates first law of thermodynamics. Option 2 violates first law of thermodynamics if Q is negative. Option 3, that is C option, violates first law of thermodynamics if Q is positive. And option D does not violate first law of thermodynamics. So in this case, as a heat engine absorbs Q1 and temperature T1 and Q2 and temperature T2. Work done by the engine is J into Q1 plus Q2. So completely work is done. So this is not possible because always mechanical energy is converted into other forms of energy. So some mechanical energy is always converted into other forms of energy, but they have given total energy into, that is J into Q1 plus Q2. That is, it is possible only for ideal heat engine, and in general there is no ideal heat engine, so which is 100% efficiency. So some amount of energy, some mechanical energy will be lost to other forms of energy. So that's why it violates first law of thermodynamics. It violates first law of thermodynamics. This data violates first law of thermodynamics. This is the answer. I hope it is clear. So this type of questions also you will get. This is previous JEE Mains question. So let us now question number 2. Let us discuss now question number 2. Question number 2. If an endothermic reaction, if an endothermic reaction is non-spontaneous at freezing point, is non-spontaneous at freezing point, is non-spontaneous at freezing point of water and becomes feasible of water and becomes feasible and becomes feasible at its boiling point, then feasible at its boiling point, then option A, delta H is negative, delta S is positive, delta H is negative, comma, delta S is positive, that is change in entropy is positive. Option B, delta H and delta S both are positive, delta H and delta S both are positive. Option C, delta H and delta S both are negative, delta H and delta S both are negative. And option D, delta H is positive, delta H is negative, delta H is positive, comma, delta S is negative. So this is the question. So in an endothermic reaction, if an endothermic reaction is non-spontaneous at freezing point, then at freezing point of water and becomes feasible at its boiling point, then what is the condition? So in this condition, at low temperature, I'm writing the answer. So for this, the solution is at a low temperature, comma, the delta S is negative. That is change in entropy is negative. That's why it is non-spontaneous. And which makes delta G positive, which makes delta G positive. But at higher temperature, delta H is negative. But at higher temperature, delta S is negative, which makes the delta G negative. So at higher temperature, delta S is positive, which makes delta G negative. That is spontaneity. So this is a solution. If you see here in an endothermic reaction, if endothermic reaction itself says that it is delta H is positive. So delta H must be positive, and it is non-spontaneous at freezing point of water and becomes feasible at its boiling point. Then both delta H and delta S are positive, because then only it is possible. If both delta H and delta S are positive, then only the reaction is feasible or spontaneous. I hope it is clear. And for this, the explanation is at low temperature the delta S is negative. That's why it is non-spontaneous. As delta S is negative, automatically delta G becomes positive. So when delta G becomes positive, the reaction is non-spontaneous. But at high temperature, that is at boiling point 100 degrees C, delta S is positive, which makes delta G negative. I hope it is clear. So this is called second question. So answer is second option. Next question. Question number 3. For each place, each page, I am giving one slide. So let us see now question number 3. I'll write question in red pen and I'll answer in blue pen. So question number 3. Let us see now question number 3. For the reaction, for the reaction, for the reactions, C plus O2 gives rise to CO2. Delta H is minus 393 joules. Delta H is equal to minus 393 joules. 2Zn plus O2. 2Zn plus O2. 2 moles of zinc plus on combination with oxygen gives rise to 2 moles of zinc oxide. 2 moles of zinc oxide. Delta H is equal to minus 412 joules. 412 joules. This is very, very important question. Now, based on this data, option 1, that is first option, carbon can oxidize zinc. Option 2, oxidation of carbon is not feasible. Oxidation of carbon is not feasible. Means the reaction is not possible. Option C, oxidation of zinc is not feasible. Oxidation of zinc is not feasible. Option D, option D, zinc can oxidize carbon. Zinc can oxidize carbon. So out of these 4 options, what is the right answer? Let us discuss now. So for the reaction, C plus O2 gives rise to CO2. Delta H is minus 393 kilojoules, sorry, joules, and 2 moles of zinc on reaction with oxygen forms 2 moles of zinc oxide. Delta H is equal to minus 412 joules. So for this, the right answer is, let us discuss now. So they have given option 1, carbon can oxidize zinc. Option 2, oxidation of carbon is not feasible. Option 3, oxidation of zinc is not feasible. Not feasible means non-spontaneous. And zinc can oxidize carbon. Zinc can oxidize carbon. So delta H negative shows that the reaction is spontaneous. Since delta H is negative for both reaction, since delta H is negative for both reaction, The reaction is spontaneous. The reactions are spontaneous. Both the reactions are spontaneous. For that is first one, because in both the case delta H is negative. So exothermic reactions. Since delta H is negative, they are exothermic reactions. So since delta H is negative for both the reactions, so both the reactions are spontaneous. Both the reactions are spontaneous. And moreover, higher value of zinc shows that the reaction is more feasible. Higher value of zinc, higher value in case of zinc. Only symbol you neglect, minus 412 joules. So higher value of zinc shows that shows that the reaction is more feasible. Shows that the reaction is more feasible. Reaction is more feasible. So by this we can say straight away the answer: zinc can oxidize carbon. Zinc can oxidize carbon means actually it should be zinc oxide can oxidize carbon, because zinc oxide, zinc from zinc only zinc oxide form. So the answer is ZnO plus C gives us to C plus Zn plus CO. So this is a reaction. Just I'll do it here. I hope it's clear. So this is the answer now. Please see here. Next question. Question number 4. Question number 4 now. So I hope that is clear now in the previous question. So zinc can oxidize carbon. Zinc can oxidize carbon and itself undergoes reduction. Now question number 4. The correct relationship between this type of questions is also important. These are all previous JEE questions. The correct in the format. Question number 4, very, very important. This type of questions. The correct relationship between relationship between free energy change in a reaction, free energy change in a reaction, free energy change in a reaction, and the corresponding equilibrium constant, and the corresponding equilibrium constant Kc, equilibrium constant Kc is option 1, that is option A. It is minus delta G is equal to RT by N RT ln Kc. This is not RT, this is RT ln Kc, natural logarithm Kc. Option 2, second option, delta G degree is equal to RT ln into Kc. Option C, minus delta G degree is equal to RT ln is called natural logarithm Kc. And option D, delta G is equal to RT ln Kc. So they are given the correct relationship between free energy change in the reaction and the corresponding equilibrium constant Kc is. So answer is C option, because minus delta G, that is standard free energy change, because delta G is equal to, since delta GT is equal to minus 2.303 RT log Kc, actual equation, application, log base 10 Kc. So minus value, so we are shifting the minus here. So this becomes minus delta G is equal to RT ln. Ln is called natural logarithm. For substituting ln, we have to use 2.303 log Kc. So ln natural logarithm is 2.303 log Kc. So answer is third option. I hope it is clear. Next, question number 5. Question number 5. So this is previous JEE question. Next question we will discuss now. Question number 5. The enthalpies of combustion of carbon and carbon monoxide are the enthalpies. So here I don't think it is possible because it's a big question. So I'll take it in another page. Question number 5. The enthalpies of combustion, the enthalpies of combustion of carbon and carbon monoxide are minus 393.5 and minus 283 kilojoules per mole. Minus 283 kilojoules per mole, respectively. Next, respectively. Continuation. The enthalpy of formation of carbon monoxide per mole is the enthalpy of formation of carbon monoxide per mole is option 1, 110.5 kilojoules, 110.5 kilojoules. Option B, kilojoules per mole. So option B, minus 110.5 kilojoules. Option C, minus 676.5, minus 676.5 kilojoules. And option D. So all these numericals are very important. So that's why we are discussing 676.5 kilojoules. Now we need to solve this numerical. So this is previous JEE question. So please note it down the question, and first you think of yourself how to solve this question, because we have solved all these type of questions previously. So let us see now. Now I'll write the format in blue color, the solution. So solution for this. So how to solve it? So first they are given the enthalpies of combustion of carbon and carbon monoxide respectively they are given. So first we write the combustion of carbon, that is C plus O2 gives rise to CO2. In this delta H is equal to negative, that is minus 393.5 kilojoules. They have given already, kilojoules per mole. And next, combustion of carbon monoxide. So CO plus O2 gives rise to CO2. In this case, delta H is equal to minus 283 kilojoules per mole. Now they are asking us to find enthalpy for the formation of combustion of carbon monoxide. For the formation of carbon monoxide, how this carbon monoxide is formed actually. So by combining these two equations, we can say, so 1 minus 2, 1 minus 2. So we can easily find out 1 minus 2, so that it is equation 1. Take it as equation 1 and take it as equation 2. Then only we'll get. So 1 minus 2. So we can take 1 minus 2 gives C minus CO is not there. O2 minus O2 gets cancelled, and minus CO will be as it is. C minus CO is equal to, so C minus CO, O2 and O2 gets cancelled. So C minus CO, by simply doing it, easily you can understand. So this becomes 2CO because CO plus O2 gives us CO2 is not correct because 2CO. So minus 2CO, 2CO. Actually, I'll write it again. Just listen now carefully because it is not balanced. First, we have to see balancing of the equation. So let us see the balancing of the equation now. So for the second equation, 2CO plus half O2. 2CO plus half O2 gives rise to CO2. Why? Because 2CO plus half O2 gives rise to 2CO2. 2CO2. So now equation 1 minus 2 will do. If you do 1 minus 2, C minus 2CO will not form. So C 2CO plus half O2. So 2CO plus half O2 gives rise to 2CO2. This is already we have done. Now they're asking us to find just um, just equation 1 minus 2. If you do, you'll get the answer. So equation 1 minus 2, that is C minus nothing is there. So C will take as it is, and 2CO will write minus 2CO as it is. And O2 minus half O2, it becomes plus half O2. And CO2 and CO2 gives rise to, this is 2CO2 and this is CO2. So it becomes minus CO2. Minus CO2. By this you can write simply 2CO plus O2 gives rise to 2CO, 2 moles of CO, 2 moles of CO. So if you take this into consideration, 2 moles of CO. So 2CO, just forget about third equation, you will get more confusion. So if you do equation 1 minus 2, you'll get 2CO plus O2 gives rise to 2CO. So taking that into consideration, 1 minus 2 it is, that is minus 393.5 minus of 283. So it becomes minus of minus becomes plus. So it is plus into minus, becomes minus of minus becomes plus. So you'll get it as minus 110.5. How much it is? Minus 110 kilojoules. 110.5 kilojoules. 110.5 kilojoules. So answer for this is minus 110.5 kilojoules. So it is second option. Because if you do equation 2 minus 1, you'll get minus 110.5 kilojoules because minus of minus becomes plus. So that is equal to minus 393.5 plus 283. So it becomes minus 110.5 kilojoules. So answer is second option. I hope it is clear. So they'll give comparison and intermediate reaction. They ask us to find the intermediate reaction, that is enthalpy of formation of carbon monoxide per mole. So to find carbon monoxide, 2 moles of CO plus O2 gives us to 2 CO. This is the reaction. So enthalpy of formation of carbon monoxide per mole becomes 110.5 kilojoules because this is 2 moles of carbon dioxide. This is also 2 moles. So if you do, I think it is clear. Next question. Question number 6. Question number 6. Let's see question number 6 now. Delta H minus delta U. Delta H minus delta U for the formation of carbon monoxide. For the formation of carbon monoxide. Carbon monoxide from its elements. Its elements at 298 kelvins. At 298 kelvins is. So for this question, we have to use. So what is delta H? So delta H is called option 1. I'll write here. So option 1 is minus 1238.78. 1238.78 joules per mole. This is also previous JEE Mains question. Option B, this type of models we have done in class also in lectures. 1238.78 joules per mole. Option C, minus 2477.57 2477.57 joules per mole. And option D 2477.57 joules per mole. So after listening the lectures carefully, you can able to solve easily all these questions. That's why I want to show you these questions. So what is delta H minus delta U? So delta H is called what? Specific heat capacity at constant pressure, and delta U is heat capacity at constant volume. And the difference between delta H and delta U, already we know delta H is equal to delta U plus delta nRT. Delta nRT, where delta N is called number of moles of gases products minus number of moles of gases reactants. So by this we can say delta H minus delta U is equal to delta nRT. So simply straight away you can find delta nRT. So and for this delta N is equal to, we know the equation for the formation of carbon monoxide, C plus half O2 gives rise to CO. This is gas and this is gas and this is solid. So delta N is equal to 1 minus 1 by 2, that is equal to 0.5. So by this you can say 0.5 into R value is 8.314, since already we know R value is 8.314, 8.314 into 298 into 298. So if you multiply this, so it is 0.5 into 8.314 into 298. If you multiply this thing, you'll get the answer. It is equal to 1238.786 exactly joules per mole. So it is not minus, it is plus, because 1 minus half, that is 0.5. If it is minus 0.5, then this becomes answer. Since it is plus 0.5 because delta N, so for solid we should not consider. So answer is 1238.786 joules per mole. So option 2. I hope it is clear. So this is the solution for this numerical. So this is question number 6. Next, question number 7. So question number 7 now. Let us see previous NEET questions now. For a given reaction, comma, delta H is equal to 35.5. Delta H is equal to 35.5 kilojoules per mole. That is change in enthalpy. And delta S is equal to 83.6. That is change in entropy. Joules per Kelvin per mole. This is NEET 2017 question. If you want, you can check the previous NEET questions. The reaction is spontaneous at option 1 T less than 425 kelvins. Option B T greater than 425 kelvins. Option C all temperatures. And option D T is greater than 298 kelvins. So right answer we have to check now. So to find whether it is spontaneous or not, for the given reaction, whether the reaction is spontaneous or not, we should know that the condition is solution for this. I'm writing here. So please note it down in your classwork. So for the important condition is delta G is equal to negative. So standard entropy change, that is standard and the free energy change, should be negative. So we know how to find delta G. Delta G is equal to delta H minus T delta S. And we know the value of delta H, that is 35.5 kilojoules. So 35.5 into 10 to the power of 3 joules per mole minus T. Let us take temperature. Let us take it is less than 425. Let us take around 420. I will take for example into delta S. Delta S is 83.6. So if this is greater than this, 35.5 into 10 to the power of 3 means 35,500. 35,500 minus. So if 420.6, 420 to 83.6 is greater than 35,500, then it is spontaneous. Otherwise, it is not spontaneous. So let us see 420 into 83.6. So it is 35,112. So it is lesser than delta 425. If you take also, you'll get less. So T delta is. So it is lesser than this 35,112. So automatically, you'll notice that the temperature should be greater than 425 kelvins because this becomes positive value. Positive means delta G is what? If it is positive, delta G is non-spontaneous. If delta G is positive, non-spontaneous. So, but they're asking spontaneous condition. So it should be T should be greater than 425 kelvins. So if you substitute T is greater than 425, you can say simply delta G is equal to 35.5 into 10 to the power of 3, that is 35,500 minus 426 into 10 83.6. If you take into consideration, this becomes, let us see the multiplication. So 35,500 first 426.83.6, 426 into 83.6, you'll get it as 35,613. So 35,500 minus 35,613. So it is equal to 113.6. So it is negative value because negative is more. So hence delta G should be, that is T should be greater than 425 kelvins. I hope it is clear. So like this, you have to check. This is the answer. So for the spontaneity, first the condition is that delta G should be negative, then only the reaction should be spontaneous. In the first case, if you take into consideration, that is, let us take T is 420 I have taken. Even if you take 424 also, you will not get, it is not more than 35,500 because 35.5 into 10 to the power of 3. Why you have taken 10 to the power of 3? Because they have given delta G, delta H value kilojoules per mole. So we have to convert them into joules per mole because this is in joules. So to convert them into joules per mole, you have to multiply with 1000. So 35,500 it becomes. So minus 35,112, it is positive value. So delta G is positive, means non-spontaneous. So this is not correct. Second option I am checking. So if you get, you'll definitely you get. So if you do any one option, 100% you get. At all temperatures, it is not possible because already 425 only, less than 425 only, it is not possible. And greater than 290 K also, it is not possible. So I hope it is the answer. I hope you understood the question. Next question. Question number 8. These are all previous NEET questions. Now we are discussing question number 8, previous NEET question. Let us see. A gas is allowed to expand. This is NEET 2017 question again. A gas is allowed for NEET, at least 2-3 questions you get from this chapter. And for JEE means also at least one question minimum, is allowed to expand in a well insulated container against a constant external pressure. A constant external pressure of 2.5 atmospheres from an initial volume of 2.5 liters to a final volume of 4.5 liters. 4.5 liters. Now, the change in internal energy of the gas, the change in internal energy, internal energy of the gas in joules will be. So in joules will be. So they have given a gas is allowed to expand in a well-insulated container against a constant external pressure. External pressure is given 2.5 atmospheres from an initial volume 2.5 liters to a final volume 4.5 liters. So for this case, what we have to find the change in internal energy of the gas. So the change in internal energy of the gas will be, so it is answer first option wise. I will write options first. 1136.25 joules. Option B, minus 500 joules. Option C, minus 595 joules. Very close the options are given. And option D means you have to do accurate calculation plus 595 joules. Let us take now. Since a gas is allowed to expand in a well insulated, very insulated means it is isolated system. So container again is a constant external pressure of 2.5 external. So pressure is equal to 2.5 and volume V1 is equal to 2.5 liters. This is 2.5 atmospheres and V2 is equal to how much? It is 4.5 liters. So we already know that external work, so work done is equal to minus P delta V. Since this is adiabatic process, so work done is equal to minus P delta V. So work done is equal to minus P delta V means P external. Here you can take, or you can say change in internal energy. Actually, you have to use the equation. Here they are not asking work done, so they are asking change in internal energy. So change in internal energy delta U is equal to minus 2.303 nRT, because they have not given number of moles also. So straight away, so change in internal energy we have to find. So we have to find change in internal energy is equal to how much. So we know delta U is equal to Q plus W. In this case, it is adiabatic process because heat is constant. So we can say delta U is equal to, since Q is equal to 0 W, so W is equal to minus P delta V. So minus P is given how much? P is given external pressure is 2.5 atmospheres into delta V. So minus 2.5 into delta V. Delta V means 4.5 minus 2.5. 4.5 minus 2.5. So 4.5 minus 2.5 is 2. So minus 2.5 into 2, that is equal to minus 5 liter atmosphere. But the answer is in joules. So we already know 1 liter atmosphere is equal to 1 liter atmosphere is equal to 101.3 joules. So straight away we can take implies minus 5 into 101.3. So it is approximately equal to minus 505 joules. So answer is third option. I hope it is clear. So since this is adiabatic process, Q is equal to constant because heat is constant. We need to find the change in internal energy of the system. So from the first law of thermodynamics, we know delta U is equal to Q plus W. So since Q is equal to 0, so we can take delta U is equal to W. So W is equal to minus P delta V. So that is minus 2.5 into 2.5 into 4.5 minus 2.5 is equal to minus 5. But this is in liter atmosphere and the options are in joules. So simply 1 liter atmosphere is equal to 101.3 joules. So if you multiply this 5 into 101.3, it is approximately minus 505. So 5 into 101.3, if you take into consideration 5 into 101.3, you will get 506.5. It is approximately minus 505 joules. Minus 505 joules. So answer is third option. I hope it is clear. So this is NEET 2017 question. Next question. Next question. Question number 9. So all these questions are most important. That's why I'm discussing. so that you will understand in which areas you'll get maximum questions. So it's not one area, it is given from all the areas. So all the areas in thermodynamics is important and thermochemistry is important. For a sample of perfect gas, for a sample of perfect gas, when its pressure is changed from, when its pressure is changed from, changed actually, when its pressure is changed isothermally, when its pressure is changed isothermally from P initial to P final, from P initial to P final, P final, comma, the entropy change is given by, the entropy change, isothermal process, the entropy change is given by first option. So these are direct formulas. Delta S is equal to N R Ln, that is natural logarithm, P final by P initial. Second option, delta S is equal to N R Ln P initial by P final. Third option, delta S is equal to N R T Ln P final by P initial. And fourth option, delta S is equal to nRT. T is also there. Ln P final P initial by P final by P initial. So straight away you can say easily this answer. Delta S is equal to nR. T will not come in delta S because T and T gets cancelled. So for isothermal process, work done in isothermal process is equal to what? Work done in isothermal process minus 2.303 nRT log of P1 by P2, that is P initial by P final. For volume only we'll get free Vf by Vi, but pressure is inverse, since pressure is inversely proportional to volume, so you'll get this equation. But when you take this as delta S, this delta S is equal to delta H by T. So this, in this case, delta H becomes delta W. So W and delta H are same. So this and this gets cancelled. So T and T gets cancelled here. So by this you can say delta S is equal to, for application formula, minus 2.303 NR log of P initial by P final. So this is nothing but we can write the same thing as NR NR natural logarithm P initial by P final. So answer is what? So what is the answer now? You can say it is second option. I hope it is clear. So minus symbol will take later on. So this is the answer. So this type of numericals are most important. Direct general formulas they are asking. So please concentrate on the formulas also. Next question. This is Neet Iit-Jee 2016 question again. Question number 10. The correct thermodynamic parameters. The correct. So if you see carefully, some JEE mains questions are coming from NEET also. The correct thermodynamics conditions. The correct thermodynamic conditions for the spontaneous reaction. For the spontaneous reaction at all temperatures is, at all temperatures, very very important. So this type of question we have got it in JEE mains also. At all temperatures is, so that's why it's better to work out for NEET JEE mains as well as JEE advanced, NEET questions also, so that you can understand better. So straight questions they are giving. So first option, delta H is greater than 0 and delta S is greater than less than 0. Delta S is less than 0. Second option, delta H is less than 0, and delta S is also greater than 0. Delta S is positive, change in entropy is positive. Third option, so we can say delta H is less than 0, delta H is less than 0, and delta S is less than 0. Entropy is change in entropy is negative. Fourth option, delta H is less than 0 and delta S is equal to 0. So answer second option straight away we can say, because for the reaction to be spontaneous, delta H should be less than 0 in most of the cases at all temperatures. At all temperatures is the condition. That's why at all temperatures delta H should be less than 0, delta is greater than 0, and delta G should be negative. Delta G should be negative. So this is the continuation. So answer is second option. I hope it is clear. So this is second option. So delta H is less than 0 and delta H is greater than 0. So delta G is negative also. So these are the conditions for the spontaneity of a reaction at all temperatures. At all temperatures. This is table-based question which are discussed in lectures. Next question. This question already we have done, but still we'll do. Again, this is another model. This is also NEET 2015 question. The heat of combustion of carbon. The heat of combustion of carbon to carbon dioxide is minus 393.5 kilojoules per mole. The heat released upon the heat released upon straight simple question. This model already we have done in lectures, so you can think it easily. Upon the formation of 35.2 grams of carbon dioxide of CO2 from carbon and oxygen gases, from carbon and oxygen gas is option A minus 315 kilojoules, option B plus 315 kilojoules, option C minus 630 kilojoules, and option D minus 3.15 kilojoules. So it is straight question. Option D is minus 3.15 kilojoules. So it's very simple. So we know from 1 mole of carbon dioxide is, what is the molecular weight of carbon dioxide? Carbon dioxide molecular weight is 44 grams. So 44 grams for 1 mole of carbon dioxide is giving minus 393.5 kilojoules per mole. Then 35.5 grams gives how much? So it is nothing but 35.5 into 393.5 divided by 44 with the minus sign. So they will get minus 315 kilojoules. Minus 315 kilojoules. So this is the answer. I hope it's clear. So this is applying mole concept. So whenever they are given 1 mole and they are asking us to required weight of carbon dioxide, same reaction. So it should be like this. Because you know 1 mole of carbon dioxide is 44 grams, because carbon is 12, oxygen is 16 to 32, 12 plus 32 is 44. So 44 grams is giving minus 393.5 kilojoules per mole. Then 35.5 gives how much? So this is the answer. I hope it is clear. So this type of questions are most important. Still we can discuss more and more questions. And next question number 11. Further reaction. X2O4 gives rise to 2XO2. Delta U is equal to, so X2O4 is liquid and 2XO2 is gas. In this case, delta U is equal to 2.1 kilocalories. 2.1 kilocalories, comma. Delta S is equal to 20 kilocalories. Sorry, calories per Kelvin per mole. Calories per Kelvin only, no mole is given. Next, at 300 kelvins. At 300 kelvins. Then delta G is equal to, hence delta G is equal to how much? Delta G is equal to how much? So option 1, 2.7 kilocalories. Option 2, minus 2.7 kilocalories. Option C, 9.3 kilocalories. And option D, minus 9.3 kilocalories. So this is a reaction in which liquid changes to gas, 2 moles. So delta N is equal to, so temperature is not mentioned. Since temperature is not mentioned, we can take delta U itself is delta H. Delta U itself is delta H. So delta G is equal to delta H plus minus T delta S. So T delta S. But here also temperature is not given. I hope it is. Since temperature at 300 kelvins is given, so temperature is given. So easily you can find, first we have to find delta H. So delta H can be found by using the formula delta U plus delta nRT. Since delta nRT is equal to, so delta H is equal to delta U is given 2.1 kilocalories, that is 2.1 10 to the power of 3 calories, plus delta N value is, delta N is 2 minus 0, because delta N is equal to 2 minus 0 because it is liquid. So it is equal to 2. Products minus reactants. So 2 into R value is 8.314 into T value. T value is how much? T value is 300 kelvins. So first we have to find delta U. Then from delta U we can find delta H. So let us take, this is 2100 plus delta N is 2 into 8.314. Let us multiply this, 2 into 8.314 into 300 is equal to 4988.4. So it is equal to plus 2100. We have to substitute 7088.4 joules, which can be taken as divided by 1000. If we take 7.0, anyway, we'll take this only, 7888.4 joules. Now delta G is equal to delta H, that is 7088.4 minus T. T value is 300 into delta S, that is 20. So 300 into 20, it is nothing but 6000. So 300 into 20 is equal to 6000. So by this you can say delta G is equal to 7088.4 minus 600. Sorry, 6000 minus 6000 is equal to 1088. 1088.4 calories. Oh, here we have taken mistake here because they have given calories, so definitely you should multiply with 2, because when the answer is in calories, so we have to take in calories only, so we should not consider. That's what here the mistake. So please note it down. Here we have to multiply with not 2.2, it should be multiplied with 2 only. 2 only, because in calories means R value is equal to 2 in calories. So when the energy is in given in calories, R value is equal to, so please, I forgot it. So 2 into 2 into 300. So this should be 2 to the 4, 4th is a 1200. So this should be not 49,000, this should be 1200. 1200. 2 to the 4, 4th is a 4 into 300. Sorry, 300 into 4, it is 1200. So 2100 plus 1200 becomes 3200. This becomes how much? Here I'm wrapping it again. So this becomes 3200 calories. That's what I'm seeing here. So it is 3300 calories. So now see 3300 calories. And here also we should change the unit of this is calories per Kelvin only it's given. So 3300 minus, so this should be taken as 3300 minus 6000. 3300 minus 6000 because 20 into 300 is 6000. So 6000 minus 3300 is nothing but 2700. So it is minus 2700 is equal to how much? Minus 2700. So units also very important. Sometimes we are forgetting this. So minus 2700 calories. This we can take it as minus 2.7 kilocalories. So answer is second option. I hope it is clear. So this is the second option. So this is the thing we have to substitute. So this type of question is very important. Since they have given delta U, we need to find delta S, and they have given delta U and delta S and 300 kelvins. So straight away we can find delta U by using the formula delta H is equal to delta U plus delta nRT. Since delta N is equal to 2 minus 0, it is 2. So delta U is 2.1 in 10 to the power of 3 because kilocalories they have given. I thought it is kilojoules. That's why we have got a mistake. So you have to carefully see the units. So 2.1 10 to the power of 3 plus 2 into, because delta N value is 2 and R value is equal to 2 in calories, because very, very important. When all the energies are given in calories, so we should take R is equal to 2. 2 into 2 into 300. So it is 1200. So 3300. 3300 minus 6000. It is equal to minus, because the value of delta G is equal to, what is the formula? Delta G is equal to delta H minus T delta S. Delta H is given. So this step we have to avoid. So this is equal to 3300. I have tried here again. So this should be 3300 minus 300 into 20. That is T delta S. So it is equal to 3300 minus 6000. So minus 2700 kilocalories. Sorry, minus 2700 calories. It becomes minus 2.7 kilocalories. I hope it is clear. Now let us see the summary of the chapter. Now we are going to discuss. Let us discuss the summary of the chapter. So before going to this type of questions we have done. So previous NEET and JEE Mains questions you do properly by seeing the models which you have covered in the class. So now we'll take summary of the chapter. Summary of the chapter. So in the first case, first we have done thermodynamics part. In thermodynamics, the important formulas are, first one, delta U is equal to Q plus W. That is first law of thermodynamics. Second one, W is equal to minus P delta V. And also isothermal reversible process, W is equal to minus 2.303 nRT log of V2 by V1. So like these questions, and R log of P1 by P2 in case of pressure. So both I'm combining here. So this is the work done in isothermal reversible expansion. Work done is equal to minus P delta V, delta U is equal to Q plus delta V. And second, what we have done in thermodynamics with respect to chemicals. So this is thermochemistry now. So first law of thermodynamics is over. Next we have done second thermochemistry. So in thermochemistry, second what we have done is thermochemistry. In thermochemistry, thermochemistry, thermochemistry. So with this, what is important? First one, in thermochemistry, heat of reactions, that is delta H, how to calculate delta H, and delta H minus delta U. Delta H is equal to delta U plus delta nRT. This formula is most important. From this you will get maximum number of questions. From this also you will get. And also heat of reaction is equal to delta H of formation of reaction is equal to heat sigma of heat of products minus sigma of heat of reactants. And also if the bond enthalpies are given, delta H of the reaction is equal to sigma of bond enthalpies of reactants minus sigma of bond enthalpies of products. So next we have fourth one, entropy and spontaneity, and fifth one we have Gibbs free energy change. Gibbs free energy change. So all these topics we have to do compulsory. Gibbs free energy. So first part as well as second part, both are very important. So most of the numericals we have done. What are the numericals we have done in all the lectures? That is most important. So please follow that and do more number of questions based on this. So if you listen all the lectures thoroughly, easily you can understand the concept. And first you should write the notes whenever you see the PPT. Then if you listen carefully, automatically you will understand easily the concept. And after understanding the concept, if you open any entrance book, you can do many questions based on thermodynamics and thermochemistry. This chapter is very important. So with this, I'm ending this chapter. I hope it is clear. So thank you all. And more important, so please do it carefully. Maximum number of questions you try to solve from competitive entrance exam books. So I hope you understood the concept here easily. So whenever we have offline class, we'll discuss more. Thank you all.